So for today, we're going to continue our discussion about the discrete time signal in digital signal processing. And we are going to talk about even and odd part sequence of the discrete time signal. So last time we have discussed the basics or getting the periodicity in the period, okay, and testing if the signal is periodic or aperiodic. So for now, we are going to get the even and odd part of the discrete time signal. So as we all know, even discrete time signal can be decomposed into its even and part composition. So what we are going to do is we are going to use this two formulas right here that we have. This one is for getting the even part, and this one is getting for the odd part. So what is this? To get the symmetric signal x e of n of the even part, we have to use the formula 1/2 multiplied by the x of n plus the x of the negative n, of which x of the negative n is the flipped signal. Okay, so my mistake, this should be, the second one should be minus. Okay, so for the odd part, instead of plus, it's minus. Okay, so how do we do that? We can decompose the discrete time signal into its even and odd function. And when we add these two, we will be getting the original signal. Okay. So let's try. So for example, we have the even a signal here that is 3 to 145 with n equals 0 at 2. So the very first thing we do if we are going to find the even and the odd part of that signal is that first, we must need to get the x of negative n. So x of negative n means since we are flipping, okay, we are flipping the signal, okay? So if that is your signal, 3 to 145, if I'm going to plot that, let's say, so I have 2 here as my 0, okay, and I have 3 here as my negative 1 in terms of f, okay, and I have 1 here in terms of 1, and I have a 4 here in terms of my 0, 1, 2, and of my 3 is 5. Let's say this is 5. So what does x sub negative n means is that this signal must be flipped, okay? Must be flipped over. So if I flip that, it's just as if I'm holding the signal. It's just as if I'm holding the signal at 0 and then flip the signal. So that's one way of manipulating the signal. So the signal becomes like this. Of course, the 2 will still be at 0. Okay, but what happens is that this 3 now becomes in this position, 1. And the rest becomes flipped. So we have 1 here at the negative 1. Okay, and we have 4 here. This is 3. This is 4. Okay, and then we have for the negative 2, and then we have 5 lastly for the negative 3. Okay, or for the 3. 5 for the negative 3 of n. So you can notice that the signal has been flipped, has been folded. So it has been flipped. That's what the x of negative n means. Okay, so right now, if I'm going to write the x of n, so what happens is that this becomes my 2 still at n equals 0, or I'm sorry, it should be written here. So we have 5, 4, 1, 2, and 3, and still the n equals 0 is still at 2. So that's how you flip, that's how you get the x of negative n of every discrete time signal. You just flip the signal at about n equals 0, and you will get the folded signal or flipped signal. Okay, so why do we need to get that? Because in the equation, for the even part, we have to use the x of e of n equals 1/2, okay, of x of n plus x of negative n for every values of n. So we have x of negative n here, okay? So the purpose of getting x of negative n is to know where do we start, okay? What are the elements of the even part? So since we're going to take a look at the n here, the lowest n here, the lowest n here is n equals, this is -1 to -3, okay? So this is n equals -1 on the original signal. So we are going to get to the lowest, okay, number of n, both for the flipped and for the original, and get for the highest of n. So this is 0, 1, 2, 3, n equals 3, and this is n equals 1. So we're going to get for the values of n from -3 to +3. So because that is the lowest element appearing on both x sub n and x sub negative n, and 3 is the highest appearing on the x sub n and the x sub negative n. So this is only 1, but this is 3. So we have to consider -3 to 3. So how do we do that? Very simple. So if we substitute x of e of -3, so we're going to -3, -2, -1, 0, 1, 2, 3 to get the even part. So we have x of -3, we have x of 1/2, so x of -3, plus we have x of the negative -3 here. Okay, so take note that we have negative here, negative of negative, and we have n equals negative. So negative of negative. So this becomes 1/2 x of -3 plus x of 3, the +3. Okay. So, and then we're going to go to the original signal. Our reference for this is the original signal from which we are going to derive the values of the amplitudes. So what happens? We have 1/2. Okay. What is x -3? Since there are no -3 of the value of n here, so this must be 0 for the x of n. And then plus x of 3 of the original value, we have 5. Okay. So that must be 5/2. So this is the amplitude of at x equals -3 of the even part. So doing that for the rest of the numbers, so we have 1/2 of x of -2 plus x of 2. So our reference again is the original signal. So we have x of -2, we have 1/2 x of -2. Do we have -2? We don't have. So this is our reference. Okay, don't be confused. Okay, I'll just copy paste it here so that you can see it even clearly here. Oh. So we have a reference here. Okay, the x of -2 is 0 since there are no -2 here. The lowest is -1, so we have 0 plus x of 2. The x of 2 is 4, so that would be 4 all over 2 or simply 2. So that's the amplitude for x equals the -2. How about x of -1? So we have 1/2. Okay, x of -1 plus x of the negative of -1. Okay, take note because of that negative here in the formula. It becomes negative. So we have 1/2 x of -1, that's 3. Okay, finally we have -1 here, and x of +1, we have +1 here for n equals 1 is 1. Okay, so that becomes 3 plus 1, 4 all over 2, still 2. Okay, about x of 0, okay, for the even part, this is all for the even part. So you have 1/2 x of 0 plus x of the negative of 0. Okay, so x of 0 is 2, of course. So we have x equals 2 here, 1/2 So x of n equals 0 is the amplitude is 2. So we have 2. Negative 0 is still 0. So that's 2 still. So 4 all over 2, that becomes 2 again. And for n equals 1, so we have x of 1 plus x of the negative of 1, which means becomes 1. Okay, so the negative of 1 is 1. So you have 1/2. We have 1. Our value is 1. Plus the x of negative 1 is 3. Okay? So again, the value is 4 all over 2 or simply 2. So it doesn't always equate with 2, but it so happened in this example, it always, the answer is 2. But that is not necessarily the case. And if we have xe last, second to the last, we have xe of 2. So we have 1/2 x of 2 plus x of the negative of 2 because of the negative n. So we negate that 2. So we have 1/2 x of 2 would be 4. And negative 2, there's no negative 2 here. So we have 0 as the amplitude. So still, the answer is 2. Okay. So and lastly, we have x of even part of 3. N equals 3. So you have 1/2 x of 3 plus x of the negative 3. Okay, and then we have 1/2. So we have x of 3, that's 5. Plus x of negative 3, we don't have. So that's 0. So we end up with 5/2. So now we have completed the even part. The even part of this signal is as follows. So again, we start with the negative 3. So we have 5/2. For the negative 3, we have 5/2. For the negative 2, we have 2. Okay, for the negative 1, we have 2. Okay, 0 is 2 also. So let me just write this as this, indicating that this is n equals 0. Okay, so we have 2, 2, 2, and then again 2 for 1, 2 for 2, and then 5/2, another 5/2 for 3. Okay, n equals 3. So this is our even part. Okay, how about getting the odd part? Getting the odd part is the same. Okay, so if you want to get the odd part, okay, so what are we going to do is still the same, but the formula becomes now minus. So x of n minus x of negative n. Okay, so again, we're going to get from n equals negative 3 to 3. Okay, so we're going to get from n equals 3 to negative 3 to 3. Okay, so we're going to start with x of add of negative 3. So we have 1/2 x of negative 3 minus x of negative 3. Okay, it's negative of negative 3. So this becomes 1/2 x of negative 3 minus x of 3. Okay, and looking at the reference signal, original signal, x of n, do we have negative 3? We don't have, so that becomes 0. Then minus x of the positive 3, that becomes 5. So that becomes negative 5/2. That's the first amplitude for x of the odd part in negative 3. How about n equals negative 2? So I have 1/2 x of negative 2 minus x of negative 2. Okay, so that becomes 1/2 x of negative 2 minus x of 2. Yeah. So we have 1/2 x of negative 2. Negative 2 is 0 minus x of 2 is 4. Okay, so that becomes 4 all over negative 4 all over 2. That becomes negative 2. So for x add of negative 1. So we have 1/2 x of negative 1 minus x of negative 1 becomes positive 1. Okay. So we have negative 1. We have the value of negative 1, the amplitude is 3. So we have 3 here minus x of 1. What's the x of 1? We have 1. Okay, so we have 3 minus 1 is 2. 2 times 1/2 is 1. Okay, so that will be our x of -1. How about x odd part of 0? So you have 1/2 x of 0 minus x of the negative of 0. So still, it's the same, still x of 0. So we have 2 minus 2. Okay, so because x of 0 is 2 here, and x of -0 is still x of 0, which is 2. 2 minus 2, that would be 0. Okay, and then we have x of odd of 1. We have 1/2 x of 1 minus, okay, x of -1. Okay, don't forget that's negative n. So 1/2 x of 1 would be 1. Okay, minus -1 is 3. So we have 1 minus 3 is -2. -2 times 1/2 is -1. Okay. So last two, we have for n equals 2. So we have 1/2 x of 2 minus x of -2. So you have 1/2 x of 2 here in our reference is 4. So we have -2. We don't have -2 here. It's only -1. So that would be 0. The amplitude is 0. So we have 2. Last but not the least, we have x of 3. We have 1/2 x of 3 minus x of -3. So we have 1/2 x of 3. What is x of 3? We have 5. Okay, the amplitude is 5. So you have 5 minus x of -3 is 0. So that would be 5/2. So that would be the result of the our function or our result. So in rewriting the add part of this signal, of this given discrete signal, we must start with -3. That's -2 or -5/2. I mean, so -5/2. Then we have -2. We have 1, and then for 0 n equals 0, it's 0. So we are going to just put a mark here of n equals 0, and then we have -1, 2, and 5/2 here. So this is the add part. Okay, so what happens is that if we add, okay, that's the even and odd part, okay, of the signal. So we say a while ago that if we add, that this add part and even part is just the decomposition of the original signal, so that if we add these two function, if we add this odd and even, what will happen is that we will be going back to the original signal. So let's try. So it is said that x of n equals the even part plus the odd part. So how do we add these two? We will be adding this by unit, position by position. So we have 5/2 plus -5/2, it's 0. This one, okay? And -2 plus 2, that is 0. And 2 plus 1, okay, that's 3. And then 2 plus 0, because this is n equals 0. So 2 plus 0 is 2. Then we have 2 plus -1, that's 1. Then we have 2 plus 2, that's 4. And then we have 5/2 plus we have 5/2. Okay. So what will happen? 2.5 plus 2.5, that's 5. Okay. So, and as we notice, we are going only to the original, we are going back to the original signal, which has this 2 is n equals 0, right? So this 2 is n equals 0. So we have proven, okay, this is the original signal that the while ago that we have referenced. So you're just going back to the original signal. So which has a unit or the elements at 3, 2, 1, 4, 5 at n equals 0 at 2. So that's how you get the even and odd, okay, decomposition of the discrete time signal. And I hope this video helped you. Okay, so thank you so much for listening. Again, this is Engr Jei Abat, and see you again when I see you on the next video. Thank you so much, and please don't forget to subscribe to our channel. Thank you and God bless.